Y'all hear me over there? Yeah. If I'm getting too soft, just do this. I'm Chris Oakwood. The name of this talk is Professional JavaScript. So I'm going to cover three things in this talk. I'm going to cover JavaScript 101, which is how it works. Number two is tips from the trenches, which is just stuff I picked up from experience and a lot of stuff I picked up from books. And the third part is unsolicited advice, which is just advice that I felt like I had to give to a group full of developers. It's not necessarily JavaScript specific. All right, so the goal for this talk is to talk, so I call it professional because there's a lot of people that write JavaScript for a living, and there's a big spectrum of this. There's people that kind of just need to get it working, and there's people that need to like understand abstract syntax trees, and they're writing like frameworks. And I don't know who's in this room, but it could be the whole spectrum. And so my approach to software development has always been to try to find the sweet spot between knowing all this theory and just getting it working, but maybe putting on technical head. So hopefully this talk is right in the sweet spot. And apologies to XKCD for that, the image if anybody recognizes it. Okay. So 101, this is how it works, and this is just going to cover syntax, and probably there's going to be a bunch of people in this room that they're going to already know all this, like half of it, and then maybe like half of the content, and then maybe the rest of half of the content people have no idea. If you know all this content, then like congratulations, you're in the right place. So there's a lot of it. I'm going to try to go quickly, but please feel free to stop me and ask if there's questions. Let's do it. Go back one. Okay. So JavaScript has types like any language. It's a loosely typed language, but there's simple types and there's objects, and these are the simple types. And I'm gonna blow through the simple types. That's what they are. So numbers, right? So integers, floats, I to the exponential 3. These are all the same type as far as JavaScript is concerned. So if you're doing 1 equals 1.2, that's true, right? That wouldn't be true in other languages. 1000 equals e to the 3, that's also true. So like 0.1 plus 0.3 does not equal, 0.1 plus 0.2 does not equal 0.3, which is obviously an error, right? And that's an error not really in JavaScript, but in like the IEEE library that JavaScript is implemented in. I don't know the name of it off the top of my head. It's some kind of base C or assembly library, and that's a bug in that library. Basically, all you need to take away from that is that if you're doing very precise floating point operations in JavaScript, you should convert to integers first. So this works. This is true. So like if you're doing with money, you should definitely know that. There's only one type of, you need to know there's only one type of number type in JavaScript. Let's do it. Okay, strings. Strings are not objects. A lot of people. You can do single quotes on strings, you can do double quotes on strings. The concatenator operator will print together. Strings have a length property that tells you the number of characters in a string. They've got several built-in methods, just a couple of them, like you can convert to uppercase, lowercase, you can do searching and such. Reference this online, right? It's good knowing these. JavaScript does not have characters, it only has strings. So that's strings. Strings are pretty versatile in JavaScript, you definitely use them a lot. Booleans, null and undefined, are what you'd expect. They're really, they're pretty standard. You never really use null. Like, they could take null out of the language. I don't think it would really be losing anything. And undefined is really lack of assignment more than it is like a type. So, use true and false, null is just there, but you never use it. Right? Okay. Objects. Everything. Everything else is an object. Right? And then here's a chart, right? So like, these are all the simple types that we covered. And then we have objects, arrays, functions, regular expressions. These are all instances of an object, and they have special properties. But just so you know, like an array is an object. If you do type of array, it will say object, which is useless, but true. Right? You also, so numbers, strings, and booleans are object-like, and that they have properties and methods. Like remember on the string slide, we had a length property and we had a method property, but they're not technically objects, they just act like objects. The string even has like a prototype you can modify, and we'll cover that later. So on to objects. All right. This is a basic object, right? It's got these curly braces. So we have an empty object here. Here's an object, right? So you have, this is a property, and this is a value, separated with a semicolon, and they're also separated by commas. Note, there's not a trailing comma here, right? So this is an object with 3 properties in each value. The name for a property can be anything, right? As long as you put it in single or double quotes. It can even be an empty string if you want. But most of the time when you're creating objects, you're going to, if it's a literal character, which means that it doesn't start with a number and doesn't have a dash in it, basically just alpha characters followed by numbers with an underscore, then you can write it without the parentheses. So most of the time when you're using objects, you're going to see like this. I just threw this in as an example. So like this is name, the value is a string, height in meters, the value is a number, right? It's an object. So we can print out like this. This is called the dot notation. So this will print King Kong as a gorilla, right? We're looking at monster name and monster type. We can change the type here. Now it's giant gorilla. And we can print, monster name is a monster height, M tall plus monster type, and that's King Kong is a 42-meter tall giant gorilla. This is called bracket notation, and this is called dot notation. It depends on the name of the property value, right? You always want to use dot notation, and in most cases you're only ever going to use dot notation. People write libraries so that you don't need to do this on property names. Basic objects. Okay, the value of an object property can be any JavaScript expression. So we've seen strings and numbers, but in this case, the value of name is another object. And this object has two properties, first and last, and the value there is string. That's weird syntax highlighting, I don't know why it's just like that, right? But this allows you to nest information. Is everyone seeing this? Right? Lights going off, maybe? So, me.name.first, that's here. Me.name.last, that's here. Right? This is, again, the dot notation. Let's see, nested objects are a powerful way to represent data, and especially when we get to arrays, we'll see you can build really powerful data structures with pure JavaScript. On to arrays. Right, so arrays are separated with the, what is it called? Square brackets. This is like all day long, can't we? Square brackets. It's very simple syntax, right? Trailing comma is not allowed, it's just like an object, right? There's zero index, so this, this is 0, 1, 2, and that's Bravo. You can contain multiple types in an array. Like you don't have to have an array of events or an array of strings. An array is just an array of any type. So here we have two numbers, a string, a number, and then an object, right? And then, let's see. So everyone see this syntax? So we're referencing the fifth element of this array, which is an object, and then using dot notation to show the property num, which is 5. So this prints 5. Right? Making sense so far? Arrays come with a link property. They come with some other methods similar to strings. You want to look at the documentation. You want to learn this stuff. Anything that you would think you might do with an array probably exists in the language. If not, you can polyfill it. We'll talk about that in a minute. So let's see what we said. Push, log, and then do like control minus control plus. So an array is just like anything else, right? Any value of an object can be an expression. Array can be part of an object's expression, right? So we have here an object with the property cities, and the value of cities is this array with 3 cities. Let's do plus. Yeah. Okay. So this is a miscellaneous slide because this isn't really about objects, but this is what JSON is, right? JSON stands for JavaScript Object Notation, and it's just a data exchange format. It's similar to XML. And I put this here in the slide because knowing what we know about objects and arrays, that's basically the definition of JSON, right? So you can see if we have, object, right, and then array. Like so, pets is a value on our top level object, and we have an array, and the array, and the array is full of objects that are types of pets, right? So everyone's seeing how that's a data structure. It's effectively the same thing as this. These are effectively the same data structure, just represented in different ways. The gotcha about JSON is that it's more restrictive than JavaScript syntax. So these always have to be in double quotes, whereas if this was pure JavaScript, you could just leave it without the quotes. What else? Yeah, it's better than XML for like all kinds of reasons. But you always have to parse it. So because this is a subset of JavaScript syntax, you could throw this into JavaScript and just say eval, and it would give you an object with an array and these properties. But that's really, really dangerous to do, especially if you're getting that from like a third-party service. There are parsing tools, and in most modern browsers, they're built into the browser, so you're not taking a performance hit when you do this. It will go through and validate that it's a valid structure, and then it's safe to load into your program. So this is used very common when you want to get data from a backend service into your front-end program. Regular expressions, another type of object. They're part of the language. I'm not going to go into how they work. That's outside the scope of this talk. But regular expressions are really powerful, and you should use them, and you should not misuse them. And if you know what that means, then you're off to a good start. But they're part of the language, and they're powerful, and they're native type, so definitely use them with strings. Don't misuse them. Okay. Let's see. Okay, on to functions. Functions are a kind of object, but they're a special object and they have all kinds of properties and they deserve their own section. So they're a fundamental unit of JavaScript, they're a fundamental unit of any language. They're objects and they execute, so a function executes within the scope of an object. And I'm going to cover that in detail. But notice I did not say that functions execute within the scope of their own object. Right? Since functions are an instance of an object, you would think, oh, they always execute within their own context, and no, they don't, which can be very confusing. We'll cover that. Let's do it. All right, here's the basics. So we have the name function, we have the name of the function, which has to be a literal. The arguments are always optional, or like they're not optional, but you're never going to get a syntax error if you don't include calling a function with the correct number of arguments. There's no checks on it, so you have to catch it yourself. But so you're getting it. All functions always return a value. In some cases that's a special value, but most of the time you just get the function with return. This is the same way as writing this, right? Technically, they're effectively the same way as far as you're concerned. What this is doing is right here to here, this is creating an anonymous function and it's assigning it to the add2 variable, but this is the same thing. Always write it like this so that you know in your head that a function is its own, you know, the function is a type and not something that's like magical. You can play with it like you play with other types. So you execute a function with parentheses, right? So result gets the result of adding 3 and 2, which is 5, right? Functions can be just like any expression. A function can be the value of a property. So we have an object, and add gets add2, which is this function, and then subtract gets an anonymous function right here. So we're creating an anonymous function here. We're assigning it to the subtract property of object 1. That makes sense? And then we can use this here. When you create an object that's got functions in this method, you call these methods. And like, don't let the syntax confuse you. It's still an object with a property, and then the value of that property is a function. But you just say method because it makes sense, right? Like object1.add, that makes sense.
Hey Chris.
Yes, sir.
On that last one.
Yes, sir.
You could also say add:\add1. Would that be correct, wouldn't it?
That would be exactly the same.
Okay.
Yes, that has to be the same.
All right, cool.
That's a good catch. Okay, so variable scope with functions. So I'm just going to go through this like line by line. So we're going to create the variable a and give it apple. We're going to create function 1. All right. Inner methods have access to outside variables. So here we have a. This is the same a as here. All right. We're taking apricot and assigning it to a, and then we're going to print out a. And then we're ending function 1. We're not executing it. We're just defining it. Right. So print out a, and we get apple. Then we execute function 1, which then changes the value of a and prints it. The result is apricot. And then we do console log a, and it's apricot. So when we executed this function on this line, we changed the value of this variable. Making sense? Okay. Alternate example is down here. B is banana. Create the function. Inside this function, we do var b. Var b is a totally separate variable than this b. Right? Different contexts. They can't ever mess with each other, right? We're assigning blueberry to b, and we're printing out b. That's just the function definition. Then we execute. So this is banana, this is blueberry, and then we print b again, and it's still banana, because this b was different than that. Everyone's seeing the difference between these two in terms of scope? I mean, they're the same except for this var. Right? The takeaway from this is that the scope of a function has access to the variables that are defined outside and above its scope. Okay, closure. So again, we're moving fast. So if you lose a little bit of this, it's okay. If you're with me up to here and then we lose you, it's okay. We'll bring it back around. So this is very powerful, and this has to do with the scope that we just learned. So we're creating counter, and then we're starting and finishing an expression. Right? Inside of this expression is an anonymous function which starts here, right, and ends here. Okay? And then at the end of this, we're going to execute it. So it means we're going to create this function, we're going to execute it immediately. We're going to assign the return value of this function to counter. Okay? Inside of this function, right, which is a totally separate scope, right, defining count as 0, and we're going to return an object. It's got 3 properties, up, down, and value. And the value of each of those properties will be functions. So this function increases by 1, decrements by 1, and then returns the value. So these inner functions, right, have access to this variable. So, okay, so we execute the function. So at this point in the code, counter equals an object with 3 functions. Okay? So then we can do that value, and it returns 0, which is the value of counter. Then we can increment 6 times in this loop. And it's going to increment the value of this variable 6 times. We print it here, it'll be 6. We can decrement by 1, it shows us 5. So the important thing here is that we have this counter object that has access to this count variable, and we have no but it's magic access, right? If we wanted to go in and change count to a string, we can't. It exists in memory, but we can't access it. Okay? Some deer in the headlights look, some people are nodding. I'm okay with that. So this is called closure, and this is a source of enormous expressive power for the language. Let's kick it.
I have a question.
Context. All right. Oh, yes, sir.
Based on the closures,
Yes.
if we don't have any power over that memory, how can we count it exists whenever we use it?
JavaScript's garbage collected by default, so we'll take care of that. So when you're done with this, like if you do delete counter, we would delete it in memory. But as a programmer, you do not have control over this. So yeah, so I guess beware. If you did this many times and you had a lot of memory in here, that might bite you. And there's techniques for dealing with that, which I'll get into when I do prototypes. Like if you have an object, like a big nasty, awesome object that you're creating many thousands of instances of, you can do memory. There's a technique for reducing the memory, and I'll cover that when I get. That's a great question. Thank you. Okay, all functions execute within a context. I said this at the beginning of the function section. I'm going to try to explain it. This is absolutely, hands down, the most confusing part of the language. And I'm not even really going into it in depth because I don't have time. But hopefully you get a little bit of it, right? So they execute in the scope of an object. The keyword this, which is a special keyword inside of a function, refers to the context in which that object is executed. And the value of this is what's confusing. Because this can be one of many different values. It depends on the invocation method. So let's see that. Okay, so here's do a control minus. Or no, leave plus. No, leave plus. Is that plus? Yeah, leave plus for now. Okay, that's good. All right. So we're defining printme, which is a function, and all that printme does is it prints this dot foo. So it's taking the context of this, looking for the property foo, and it's going to print it. So then we're going to define this object. Let me come back to that. So if you print this by itself, it's going to give you undefined. Why is it going to give undefined? Because it's going to look for this, and it's going to roll up. What happens if you don't, so like, think about scope being nested. It looks up. It looks higher and higher in scope until it finds a property. Yes?
Is print this and print me the same thing? Is that a typo?
No, they're different.
I just wanted to make
I'll
sure.
get to that.
Okay.
No, but they're not a typo. Not a typo. When you use an object property that does not exist, not found, it looks up the prototype chain, which I'll talk about in a minute. If it doesn't find it, it just throws it on the global object because it has nowhere else to throw it. And since foo does not exist in the global object, this will be undefined. Alright, so let's take a look at this object. We have an object, and in the first level of the object, we've got property foo, which is what we're looking for. And then we have a value printme. The value of printme is the function printmes. Okay? This object also has a child. The value of this child is an object. So now we're like level 2. Think Inception here. Level 1. We're going down in scope. Okay? So the value of child has foo, which is distinct from this foo. Right? And that value is level 2. And it also has a printme function, which is the same thing as print this. Right? And we keep going with different levels here. So we do this, and it gives us undefined because the foo does not exist in the global object, and it doesn't exist here. So we get nothing. We do object1.printme, and we get level 1. Makes sense? Because foo is a property of object 1, and we're executing this function in the context of object 1, so level 1. Object.child.printme executes level 2. For the same reason it's saying level 1 on the top level here. Okay? Now we get into, remember I said you don't always know what the context is. So here's a confusing example. The apply method, it may not be possible. Okay. The apply method is, remember, functions are objects. And so objects can have methods and properties, just like any other object. Apply is a function that comes with every function object. Is that confusing? Yeah, a little bit. So what we're saying with this is we're saying take object.1, or object1, child, print me, and run this function within the context of object1. So this is the child's function, and we're saying execute it in the context of the top level object, and the value is level 1. Raise your hand if you got that. Good enough. It's good enough. Okay. This is absolutely the most confusing part of the language. If you're like with me 100%, then you're golden. Go right framework. This is the same thing, right? We're just taking this, we're taking print me, which is off screen, which remember had no context at all, right? It was this.foo and didn't exist. So we're running the apply function against an object that we create right here, which has one property, foo, and we're printing it off. And I chose inception.
For maximum clarity.
For maximum clarity. Yes, sir.
The global object is window in a browser? Correct.
Yes, that's
What
correct.
is it if you're like a node or something?
I don't remember what it is. It's probably
I
something.
can't remember what it's called, but there is one.
It's something. There always has to be. So like remember, functions always execute within the scope of an object, right? So even when you're just if you don't create an object, if you just print things on the page, it's executing within the scope of something. The thing it's executing in is the global scope.
And you dirty it, and you don't call var.
Yes, yes. I get into that. I'm gonna do prototypes and stuff. Okay, let's kick it. Let's go back to control minus and roll out. Thanks, sir. All right, inheritance. So I've mentioned this thing with this chain where we're looking up in scopes. And the thing I didn't mention is that every object was created from a prototype object. So think of it like a clone-ish. So when you look for a property, and it doesn't exist on the object, so first it checks the object. Does foo exist? Yes, if it does, then here it is. If not, look for that object's prototype, and look for foo on that object's prototype. If that's it, then do it. If that doesn't exist, look at the parent object. They all roll up to the global object. And I'm going to show you examples of this. So that's what I just said, basically. It all rolls up. Every object rolls up to object with capital letter. This is a built-in object that the language gives you. It's part of the spec. Right? Okay. So here we have example of this. So we have empty object. We're printing foo. Doesn't exist, right? Doesn't exist. It doesn't exist on the object, nor does it exist on the object's prototype. Okay. So now we're going to add foo to object.prototype.foo. If anyone's wondering, the word prototype is a special property, right? This is a built-in special property of the language. That's that word prototype. I didn't make that up. That's part of the spec. So we're going to add foo to the global object's prototype. We're going to get the value of bar. Now when we print this, the same line up here, now we get bar. It didn't exist in the object, but was found in this prototype. Now let's give object 1 a foo directly, make it z. Now when we print this, it does z. It found it on the object, and it doesn't look at the object's prototype because it found it there. Right? If we remove foo from the object, we go back to the prototype. And if we remove foo from the object's prototype, we go back to undefined. So this was sort of building up and going back down in terms of defining foos. This was one level, right? We only involved the global object and the object we created. But imagine if you had an instance of a function. It would roll from that object to the function to the global object. And you can go nested as much as you want with that. Yes, sir?
Say I change the prototype for object, and then I make a new object from that prototype. Does it inherit that property automatically in the context of,
Yes, it also does it retroactively.
Oh.
Right. So if you.
Well, the reason for that is it's looking at the chain. It's not actually putting that property on every object beneath it.
But on the new objects that are created, is it actually put in there, or is it?
No.
Okay.
No.
Okay. It's just unless you explicitly add it to that object as a property, it will then look to the prototype.
Yeah.
Okay.
Yeah.
I understand.
The logic was simple.
Oh, makes sense.
Access property, if property not found, look at prototype. Not stored, prototype is there in memory. Keep looking, if not found, until we reach the top. If not found, undefined.
Chris, the delete, so when you say delete object 1.foo, you're just basically deleting the property of an object?
That's correct, that's exactly correct. I'm deleting the foo property of object 1.
So is it like the same thing as creating object one and then creating the entire, the same definition of the object, just without the property that you're trying to delete? How does it?
Yeah, but it's, I mean, but like, that would be accomplishing the same thing, but, you know, going an extra mile.
Yeah, well,
You
yeah.
know, but yeah, what you first said is exactly right. Just, you're deleting a property of an object. Right? So, and if you were to delete object one, it would delete the whole object. You wouldn't have these remnant processes. Yes, sir?
You mentioned a minute ago that they'll look to the parent sometimes too.
Yes.
Which one is more important, the prototype or the property is also on the parent?
Okay, so let's assume we're 3 levels deep. Let's use an array, because an array is an instance of
An object.
an object. Okay, so we would have global object here, array here, and let's assume that we've created an instance of an array here. Okay? And we're looking for a property on this instance. Right? We're going to check first this instance. Doesn't exist. Well, check array prototype. Right? Doesn't exist. Check object prototype. It exists. That's our value. Then on the next line, we were to add that property to array, and we checked it again. It would find it at array. So it goes up, and when it finds the first thing, it stops. So precedence is not like, the most grandfather doesn't take precedence. It's the last check. Does that make sense? Okay. Don't ever do this in practice. Don't ever modify the global object. This is just, for example. This is like a chimney curtain. Go up. This is a similar example. Same concept. So 2 objects, right? Foo not defined on either of them. Add foo to the object prototype. They both get it, right? They both get the same value. Give only object 1 z into foo. Now object 1 is z and object 2 is bar. Yeah. Delete it from the prototype. Object 1 is still z, but object 2 is now undefined. Same thing, just kind of a different way of showing it. Again, don't ever do this, unless you know what you're doing. Okay. Constructor functions. This is like I promised the most complicated slide on the deck. Right. Okay. When you use, okay, let me just, I don't know where to start with this. Okay, so we have the circle and it's a function. Okay, pass in radius. And if the radius is a number and it's greater than 0, or if it's not a number and it's not greater than 0, then we'll give it a 5, else we'll take whatever you is. And we're just going to return this dot radius, right, equals the value that we put in. What does this refer to? It refers to
Circle.
the object context, which in this case is circle. Okay, it refers to the object context. And then, let me just not talk about this for a minute. And then when you create a new circle, when you use this new keyword, and you're creating an object, if the object returns a value, then the value that it returns becomes the value here, right? If you don't return a value, like this function, do we see the return anywhere? No, we're not. It inherently returns the context of this object. Yeah, did I hear a grunt like who designed this? This is crap, right? That's definitely confusing, and you don't ever have to do this. Everything that you can accomplish with the new keyword, you can do it in other ways. So don't be scared by this, right?
It's implicitly doing return this?
It's return. Okay, remember, this is an object. We're saying create a new instance of this object, and so, you know, when we execute this from here to here, we're creating a new object, and we're returning it.
Right.
So when we do this dot radius.
Right. If you had an explicit return statement, what would it say exactly?
It would take the explicit return statement's value. So if you return like a number, it'd be a number.
Yeah. What I'm saying is it implicitly doing return this?
Yeah. Yes. That's exactly right. In fact, yeah. Just think of it like that. That's a great way to think of it. If you had the statement return this at the bottom of the function, that's what the new statement does. Again, you don't have to use this. This is totally convenient. The reason I brought this up, right? So we're going to do circle dot prototype dot area, and we're going to make a function, and we're going to return pi r squared, which last I checked was the formula for area of circle. So we're going to create a new circle, and we see we have the radius property. See when that radius is 8, which is the value we brought in, and then area, that's the area, right? C2 is a new instance of circle. We didn't pass it a default, or we didn't pass it a number, so it gets default radius of 5. You can see that here. It's 5. and the area is this. The key here, right, remember I mentioned how you can do these memory management techniques? So let's say you have this big object that represents something, and you have a function that you want to apply on that object. Well, every time you make instances of that object, let's say it's like a widget. It's a widget on the page, and you've got like 1,000 of them on the page, and they all have some function. You don't need 1,000 copies of that function. You only need one. You just need to run it against each individual object. That's what this does, right? So the area function only exists on Circle's prototype. It doesn't exist twice in memory here. So if for example, we were to go down here and write circle.prototype.area equals null, and then we ran this code again, we would get null here for both instances. Raise your hand if you're tracking me on this. Still doing okay. Still doing okay. Okay. Definitely the most confusing part of the language. Don't even worry about it if you don't get it. Okay, let's kick it. The browser. You're good. You're good. Just do a control minus and scroll up. Okay. Everything so far up to this point, pure JavaScript. Applies to Node, Rhino, browser, whatever, right? Nothing about the browser so far, except I think with the window that Lester pointed out. Pure JavaScript, right? So let's talk about the browser, because in most cases you're going to be executing JavaScript within the context of the browser. And the browser gives us context. It's like the worst part of the language. It's not actually the language itself, but the context that the browser gives us for it. Don't worry about that. So it exposes context for us to execute on. It gives us objects to use. It gives us the DOM structure of the underlying HTML, and then events. So this is where your power comes from. This is where click and the alert happens. Alright, browser context. So the global object is window. Window.documents is sort of the DOM tree. I'll cover that in just a minute. There's many other global objects. There's window dot, I don't know, there's probably like 60 of them. You know what I mean? But they're all different in multiple browsers. They're not consistent. Some are part of the spec. Some are put in by the vendors. Not consistent. Stay away. Abstract this stuff with libraries. This is the entire ethos of why things like jQuery exist. Is that you're not directly accessing these properties. In these examples, I will, to show you, so you can kind of grasp what's happening underlying the hood, but don't do it. Don't do it. Just use jQuery. Just use your library. Okay. So this is really confusing, right? So if we don't declare foo, which is really bad, you should never do this. Foo equals bar. It doesn't find it, so it rolls up to the global object, and it puts it on the global object. So this becomes window.foo, which is the same thing as saying this.foo, which is the same thing as saying window.foo. Does everyone see how these three are the same thing? This is assuming that you put a script tag here at the bottom, you put nothing else around it. This is just standalone code. These three will function the same way. Don't do this, but that's how it functions. Right. Rolling up, not finding it, throwing it out in the global because we got nowhere else to put it. This is actually the context. Put it directly in the context. Look for it, by reference. Okay. Don't do this. If you need to do it, this is the way you would do it. You would do window.myapp, and I would put it in caps, gets window.myapp or an object. What this is doing, so JavaScript has true and false as those Boolean type from the simple types, but it also has truthy and falsy values, which are values that appear truthy when you're not doing a type check to your comparison. And I'll cover that in just a minute. But basically you're saying, if window.myapp exists, don't create it again, but if it's false, then give it this empty object.
I got a question.
Yes, sir.
If you, what do you say foo equals bar?
Yeah.
What if you said document equals bar?
Then it would put it on document.
So you'd stomp on document.
So document.bar is the same thing as.
Document's
an object. And
window.document, you've got that already defined. So if you define a variable called document, will that stomp on window.document?
If you do var document, no, because that will be in that context. If you do document equals bracket, yeah, you'll blow away the document.
Okay.
I don't know this. Probably browsers have some kind of check against that. Maybe they don't.
You can do that.
You probably can.
Blow away everything else.
Yeah, you probably can. But yeah, that's exactly what it would do. It would blow it away, which is obviously very bad. That's a great question, but don't do that ever. Yes, sir.
What does note don't do this in practice? Is that for above or below?
It's for these three things.
Oh, okay.
Yeah, for those three things. Do this all day
Yeah,
long.
I couldn't tell that.
Yeah.
How long does the assignment to window.foo last? Is it scope with the page, or do you have to close your browser, or?
It's a page. Yeah, it's on the page.
Okay.
It's on the page. Yeah. I mean, the whole page has a scope. Like everything happens within this big monster golden scope, and then it can be as big or small as you want. When you leave that page, it does leave memory. So that's like a browser thing.
Right.
Okay. DOM. What is the DOM? It stands for Document Object Model. And remember how I've been showing, we've been using these objects or data structures, right? We had, remember the object that was me, it was like my name and where I lived and the latitude, longitude. That was just a pure data structure, it had no code. This is HTML, okay? HTML is a tree-like structure, yes. What's a really good way to represent a tree-like structure? Nested objects, right? Same thing, same thing. I know somebody will ask me this, I'll tell you now. No, you don't have to close your LI tags. You don't have to put parentheses around that, right? It's part of the new spec, you don't have to do that. We'll talk about it later. But that's valid HTML5 right there. So this is, the theory though, that this is, you know, a representation of this. This is not complete. When, you know, this is what the DOM looks like though, internally. It has many, many more properties, but I couldn't list them, you wouldn't be able to see it. But you can see, you know, div, IDs, pets, inner HTML, right? Tag is div. It's got a children, which is an array, that's these guys, right? First one's the H1, the value, you know. So everyone see how this is a data structure and this is a data structure? Right? This is how the browser exposes the underlying structure to you programmatically. That's what the DOM is. That's all you need to know. Except that it's inconsistent, but we'll talk about that. Right. DOM manipulation. So let's take the structure that it gives us and let's manipulate it. So same thing here. We have pets in the style of color red. So let's get that element. That's a built-in function that the browser gives us. Let's get this element, and it's got an object called style, and that style object has a property called color, which makes sense, right? Change it to blue, and it will change this to blue. This is the same thing as doing this, which probably people are more familiar with in this room. But you're doing the same thing. Right? This is what this does underlying. The reason to use a library for this stuff is because all these properties, like style.color, are inconsistent across browsers. That one probably is consistent, but there's many more that are not consistent. And these libraries make it so that that will always change your style color to blue and not like, you know, some weird subtag or something. Okay, so same context, and that we have this underlying structure represented to us by JavaScript. The browser has an event, right? Click events, mouse over events, you know, text in, like blur, you know, on click, all these events that like people are familiar with, right? And these events happen against elements in the DOM. And so when you want to make something happen, right, you're just attaching a function to the element in the DOM. Right? So again, we're going to get the element, we're saying that click, we're going to give it the value of a function, right? You clicked me, you know, print this stuff. And when we click on this element, right, it will execute that function. Make sense? So we have elements have events. You're going to assign functions to those events. That's what event handling is. Let's talk a little bit about context. So, take a guess at what the context would be when you're running a function against an element.
That element.
Exactly. That's exactly what it is, right? So console.log this is going to print the DOM element. This will print pets, and depending on your browser, you know, it will print, you know, all the stuff we saw on the previous slide. It will print inner HTML, children, the tag, all that stuff, right? They also, by default, every one of these events expects to receive an event argument that the browser gives it. And that event argument is the actual event from the browser. So for example, like, you clicked with your mouse, and we'll talk about this in the next slide, but if you click on, well, I'll talk about that in the next slide. Yes, yes.
And when you're using the library, you're going to have to pass the event argument to the function.
The library does give you access to the event, but not in this native way. I actually don't even know jQuery well enough to know where it gives it the event, but it definitely gives you access to it. It's not like
You pass it in there just like you would normally.
Is it normal? Okay, yeah.
All parameters are optional in JavaScript.
Yes. It's like both those things are true, you know. So I didn't have to pass it. Like I could take that out. It would be fine.
Can you say console.log event inside that last line?
Where, here?
No.
Oh,
inside
here.
The function. Can you say console.log?
Someone correct me about jQuery if I'm wrong, but if I were to put E here as the event,
Yes.
and do console.log E inside here, I think it would do the same thing as this.
Yeah, except it's a jQuery event instead of the native.
Instead of a native event?
Yeah.
Okay.
So you have to put it in the function as an argument before you can use it inside the function.
Yes.
It must use the arguments.
Yeah, we're not talking about outside of scope. Yes.
You can correct me if I'm wrong, this is the jQuery guy, but I think those two are slightly different because the first one, when you're assigning it to onClick, it's only, if there was previously an onClick already defined, you're replacing it. Whereas the bottom one, you're adding a new one to
Probably.
a list.
That probably, I don't know. Like that's library dependent. It's library dependent.
Right, but that's something to watch out for, especially like with window onload. You think you might be adding to the chain, but you might be replacing any previous.
That's a really good example. Yeah. Yeah. Don't. So like again, don't do this. Do this. But understand that this is how it works. It's not any more complicated than an object that you're assigning a function to. Right. Use these libraries, but that's fundamentally that's what's going on underneath it. But still take your target Jiffy Lube. That's what I'm trying to say. Okay, event bubbling. So when you click on the slide we have a little H1 in the list. If you click on fish, right, and you have an event handler attached to pets, what the browser will do is it will take the event on this element and it will look for a handler for it. This is real similar to what happened with the object prototype. It will look for a handler. If you didn't find one, it will roll up to the next one, the next one, the next one, all the way up to HTML. So you can attach to like the body tag. You can attach onClick, click alert, and then like anywhere on the page someone clicks, it will just like alert them. Right? Don't do that, please. But that's how it works. It bubbles up to the top. Okay. And if it doesn't find anything, it doesn't do anything. So this is real similar to the JavaScript object chain. Can you guess why they're similar? Right? Like, so there's a reason for that. Yeah.
Does the event bubbling stop when it finds the match, or it just goes up all the way?
I think it stops when it finds the match. I know it depends. If you return a false or something, it will stop.
Return false or
prevent the event. Yeah, you can prevent it. You can either have it not do it or do it, depending on what you do inside the function. If you, it's a, what is it? It's
stop propagation.
It's like event. Yeah, it's event.stop propagation. It's a method on the event object that gets passed in that prevents it from going. Correct? Is that correct?
Yeah.
Don't do this stuff. Use the library. Read the library documentation. But this is how it works. So this is important. You need to know how this works. If you attach the event here, you can use, like in this case, I'm checking the tag name and I'm checking the class name. All right. So every time we click on all these, it's going to execute this function. But it's only going to alert at us if the tag name is an li and the class name is doggy. Right. So how many events have we attached? Just one. But we're only targeting this element. So this becomes important when you have a page with a lot of things to click on. Because event handlers can be expensive. They can cause the browser to slow down. So you don't want like 2,000 event handlers on a page. At most you want, I don't know, you want more than like 20. Right? So you can use things like this to target it that will reduce your actual number of handlers. And the jQuery libraries, all modern libraries, give you really, really awesome ways to do this. So instead of having to do stuff like this, you can do a CSS selector. Right? Just like you do with jQuery. So that's event bubbling, event delegating, bubbling. And you need to know how that works. One more thing, and then we'll go. So again, the context of this is the element that it was on, but the event would be for this. Right? See, I'm doing event.target. Makes sense. Who's with me on this? Who's got it? Okay. I feel like you guys probably knew this all coming in. Okay, that's how it works, with minimal opinion on how you should make it work. This is going to be opinion on how you should make it work. Let me say the caveat that, like, a lot of this is I did not create this. This is not original content. All of this content is basically from reading books, reading blogs, and like a little bit from personal experience. So let's keep it. All right. So never, ever, mostly never, right? Never use eval. So eval is this function. You put a string in it, and it executes the string as if it were JavaScript code. There is never a reason ever to do this function. There is always a better way to accomplish whatever you're trying to accomplish than using eval. Okay? Raise your hand if you're going to write eval in the future, ever. Put your hand out. All right. Never use set timeout with a string, okay? Which is the same thing as eval. You can put a function literal here, and it will accomplish the same thing. Never do this. Never use the with keyword. It's weird. It has to do with assigning object context, and don't ever use it. Don't do browser detection to check for a feature. Use feature detection. So what that means is, let's say, remember how the browser gives you these contexts, like these global objects you can use, like XML HTTP request or WebSockets or something. Don't ever check if IE6 do this, if Chrome do this. Check for that object existing specifically, or check for that method or property existing specifically. In reality, never do that anyway. Just use a library. That's why libraries exist. Libraries are like flowers that grow over barbed wire. Like, it's barbed wire, we don't want you here. No, beautiful flowers. Use the flowers. Like, use the flowers. Okay? So, mostly never do this stuff, like, pretty much never do this stuff, unless you really know what you're doing. Don't use document.write or document.writeline. These slow down the execution of JavaScript. And they're blocking. Do you know JavaScript from time to time? I do a little bit. Dabble? Okay, so let me explain how this works. When you load JavaScript on a page, when you include script, the browser is reading the document, it hits script, it stops, it executes that code. And if it needs to fetch it, it will go fetch it. But as soon as it receives it, it will execute. And then it will load more document, then it will load more code, depending on if you have script, right? It always happens in this top to bottom fashion, and it always stops, and it does it, and then it moves on, right? These two functions, so like the act of parsing the DOM and the act of executing the JavaScript are two separate browser functions, right? This messes with that. It gets in the way of the parser. And so a lot of times in a modern browser, we'll have to parse all of it and then like go back and then like reparse it. Just don't do this. It's not good. Don't add to global objects prototype right before. The exception to this is a polyfill. And so I'm using object here, but this also refers to array and function and all the other global ones. The exception is a polyfill. What is a polyfill? A polyfill is a function that you add to the prototype that gives properties to it that it wouldn't already have. So for example, let's say on the array object, you want a method called each. Array.each. So the each is basically like a map reduce for arrays. Like you can do array with items.each and then a function that will apply that function to each element in the array and then send it back to you. That's awesome. We want to use that, right? It doesn't exist IE6, sorry. But it doesn't exist in modern browsers, right? It's native. So you can say if array.each, if it does not exist, then add it to the prototype. And so you can go on MDN docs and Mozilla docs, and they've got a list of like, so basically if you want to use modern browser functions and your old browser doesn't have them, Mozilla will give you a way to add them. And when you do that, it's called a polyfill. But you should basically only be modifying these global objects if you're copying it directly from MDN. Right? You shouldn't add, my app function onto array. You should create a new object for that and leave array as array. It will mess with other libraries and stuff. Did you have a question?
What's the substitute for document write and document write line?
There's not, don't do it.
Well, okay.
So what that does is it stops execution and it puts it in the DOM immediately. So if you want to do
so there's no reason you would ever want that.
There is one reason.
Function.
The only reason this is not in the never never is because there are times when you want to write the script tag into the page. But since I don't think you work for Google, so you don't need to do that. You know what I mean?
Not yet.
But it's like there's a thing, if the jQuery object doesn't exist, then write into the DOM literally script source equals the jQuery CDN close tag, right? And if you look at the Google Analytics, they're doing that. They write directly into the document the URL for Google Analytics. You don't need to do it. Okay. Unless you know you need to do it. Unless you know what I mean? You don't need to do it.
So I think another common example is if you have a bookmarklet, but you want to store the actual code off on your server, that way the person doesn't have to update their bookmarklet every time, it just points to the source that you update. So the bookmarklet is basically just saying, go grab my script, and then you can update it on your server whenever you make changes, whatever. And the person doesn't have to reinstall the bookmarklet.
Don't even know what that is. But probably. I don't know. Probably. You sound like you know what you're talking about.
Hey Chris.
Okay. Yes, he was calling.
Well, one thing about this is that with document.write is for building dynamic content, but there's other better ways of building
like HTML.
Yeah.
Yes. That's
the gist. Yeah, that is the gist of what I'm saying. If you know of exception, you know what I mean? Do it.
So
that's why it's not the never never.
What's the substitute for write line?
Write line is just this with a new line.
Dot enter HTML.
The same thing.
You want to end it.
I didn't realize.
The reason people do this, people will do that. They'll write a Ruby loop that says you know, echo, or that would be PHP, but you know, echo document.write the content. Don't do that. Better ways. All right. So mostly never, never, mostly never, and now always, always, and mostly always. Okay. It's 2012, and you should always have this at the very top of every HTML document you produce. All right? So this is part of. If anyone recognizes that, that is the doc type for HTML5. Why is that the doc type for HTML5? It's not because they created that. That has been reverse engineered from old browsers. Okay, so that's the minimum text required for basically every browser on the planet to enter into standards mode. Browsers have operability mode and bad mode, and they have standards mode where they're expecting solid markup and they're going to operate in a consistent manner. That text will put every browser on the planet into standards mode, and that's why it's the doc type for HTML. It's not, they didn't come up with that. They basically reverse engineered that out of the browsers that were in existence. You should always put browsers in standards mode. There's never a reason. Yeah.
That puts all modern browsers in.
No, that puts all browsers. That puts IE5 in standards mode.
Really?
Thank you. Yeah, that's why it's like that. So a lot of the, there's a talk, I give a link to a talk later, like, remember with the li tags, you have to close li tags? There's a really good talk on, like, the real changes in HTML5 by Paul Irish. I mean, everyone knows, like, the cool stuff, oh, WebSockets and all this jazz, but there's a lot of, like, really solid fundamental engineering stuff they add. And this is an example of something, right? Okay, so do that. The parseInt is a function that gives you, and you take a string or an integer, and it just returns an integer. And because of the way that it works, if you have a 0, if you have a string that starts with a 0, it will think that that's not base 10 number, right? So no matter what, always parseInt, add the radix, which is 10, or I mean, probably is 10 in your application, right? It's like you should do a grep on your code base for parseInt, and if it doesn't have 10, you should add it, right? That's always safe to do. And I've already mentioned this, but you have to parse JSON. You can't just trust JSON. You should parse it and make sure that it's well formed. Mostly never. I'm sorry, mostly always. Always do this stuff. There's very few reasons not to do this stuff. Do explicit type checking. So like JavaScript has a double operator and a you know, like that, without the triple, and it doesn't check type. And this is really true for any loosely typed language, but especially in JavaScript. It's always going to benefit you to always do type checking against your variables.
Hey Chris, what
Yes.
about less than or equal to?
Does it even have type checking on it?
I don't know. I wonder why there's no like less than equal equal.
Because I don't know. It's I don't know. What would it do? What would it
Is
do?
that, yeah, that's not what it do.
Well, I mean,
I don't think that exists in this one. I could be wrong about that. Does anyone know if I'm wrong about that?
I don't know.
I think you would have to interpret it into a different type before it can compare it. I mean, you can't compare two different types.
Yeah.
Wouldn't it
yeah,
come back
that's-
undefined?
Yep. I don't know. I'm not even sure that's an operator. I should know that. Yeah, whack. I mean, these are the ones that you really have to worry about. So, like, if you're worried about that, do a type conversion on each side of it.
Right.
Yeah. Okay. Don't put code directly onto the page. Put it script tags. This is really on the. This is kind of between. This is the never, never, and always, always, and this is kind of here. But I wanted to include it because it's just always better to do this. Right? It's just better to do that, unless you're trying to remove an extra HTTP request on a page that has none, something like that. In most cases, you're going to put it in the script tag. Don't load it on the page. Just don't do that. Add event handlers into DOM programmatically. Don't put them in the markup. You can do this. It's not like the browser's not going to explode, but you've seen this. You've seen div onClick equals function, and unless you've got like your nested scope set up globally before that happens in the DOM, then what scope's going to execute on? It's going to execute on the global scope. You don't want that. Add them programmatically after the fact. It also lets you execute functions in the scope of your choosing, which I'll talk about in my next slide with you. What else? Use a library to abstract almost anything that the browser gives you. You never want to access this stuff directly unless you know all it. Unless you memorize every browser. Every browser is complicated DOM off the top of your head. Just use a library. That's the best way to say that. Okay. Boom. Front-end optimizations. Man, my favorite / most hated topic. I love things that are fast, and I spend a lot of time making things fast, and it bothers me when people don't know why things aren't fast, or they have the wrong idea about it. So Yahoo published some rules many years ago. Steve Saunders published a book. It basically says the same thing as the Yahoo rules do. You don't need to read the books. Just read the rules. Because really, the first like 4 rules matter 90% more than the rest of the rules. So, like, you know, the top rule, it's this phrase right here. Don't be penny wise and pound foolish. Right? Know where you're optimizing before you optimize. It's just like the old Donald Knuth, you know, optimizations are the root of evil. Know what you're doing before you decide to refactor and optimize. Less HTTP request is the #1 thing anybody can do. It's more important than anything else you can do, unless you have like an infinite loop, right? In making your page run faster. The second thing you can do is put CSS in the head and scripts at the bottom. Those 3 things, that's 99% of optimization, right? So like, this is real. Actually, I'll show you this. I'm going to call them out on this. So, who's heard of Twitter Bootstrap? Right? Twitter Bootstrap is this great product. I think it's just right here.
Massive section.
Yeah, here it is. Okay, ready? So here we go. Yeah, placed at the end of the document so pages load faster. Yes, but you have 15 of them, so no, right? Roll them into one and put it at the top of the page. That will be faster than doing this. So this is an example of someone who, you know, had their heart in the right place and like, this is wrong, right? This is, you'd rather have these as one file at the top of the page than 15 at the bottom. That's how it works, and you know, you should know that.
Why can't you have one file at the bottom?
That would be optimal. I'm just saying, like, that would be better.
Async and defer, which attributes it.
Yeah, you can do that. That's, like, I'm not going to.
So you're saying like no matter how big your file is, put it into one file?
Okay. Here's what you should do. You should always put one CSS file in the head, as few as possible in the bottom. That's it. Nowhere else. Yes?
Hey Chris, just so you guys get a bit of more scope of how important that is. I've seen some pages even like, instead of having one script file, they put all their script in a script tag. Like, they won't even request for the file.
Yeah.
They'll just have it there.
Yeah.
I mean, it's that important, really.
Yeah, this stuff is important. Stuff's important, and it really matters more than you might think. So, while you're at, you know, probably you're going to have to combine scripts, right? You're going to have scripts in multiple locations. While you're at it, throw it through a minifier, right? You're going to concatenate these files to get it down to one request. Throw it through a compressor, YUI compressor, Google Closure compressor, whatever the newest one is, you know, put it on the page. I'm going to talk about that when I talk about build scripts. But don't worry about optimizing CSS with these 2 exceptions. Don't use expressions. I don't even know what they are. There's some kind of IE thing. Just don't use them. I don't know if they could. Look them up. And don't use star in your selectors. This isn't even as important as it used to be a couple years ago. Modern browsers deal with this pretty elegantly. But beyond this, there's like nothing you can do to optimize CSS. CSS is one of the fastest things you can do in a browser. And if anybody tells you we need to refactor the CSS to make it faster, just tell them that they're micro-optimizing because it's there. There are 2 books on that. I'll go back. There are 2 books on this if you're really interested in this topic. Steve Saunders wrote one, and I think Stefan wrote the second one. There are O'Reilly books. It's called High Performance Websites and Even Faster Websites. They're good books if you're really interested. Dig into them, but do those, or you just do these 3 things, and you know, 80-20 rule, or you're gonna get. Right? So. Okay, so this gets into what I'm saying. So you do have like a development environment and a production environment, right? You're not editing live on the server, right? Okay. So in development, you know, you want. Yeah. No, in development, it doesn't really matter. You want your stuff not to be concatenated and not compressed. So it's going to look like this, roughly. And then in production, though, you want to concatenate these things, and you want to change the file name, right? Change the file name so that when you change the content, it busts the cache of whatever browser is going to request the file next. Everyone see this? This makes sense? Let's do this one. Okay. This is kind of like a for most people in the room advice. Like if you are doing async and you know what you're doing, this doesn't matter to you, right? For most people, this is what you want to do. You want to include on every page. You have a web application. It's got in pages, right? 100 pages, 1,000 pages. A lot of stuff on those pages is repeated. all of your CSS should fit into one file. If it doesn't, I don't know, like you're going crazy with your CSS, right? But pretty much you should be able to fit all your CSS into a single file rolled up. Maybe you have a base and a reset, and then you have your actual styles. So maybe you have 2 files. But in production, make it 1, right? You're reducing the requests. Then you're going to have some kind of library, jQuery, YUI, whatever. Then you're going to have some kind of, and this may not be true for everybody, but you're probably going to have some kind of global library with functions that you need on every page, right? So maybe it's code that executes for your header, footer. Maybe it's some kind of library you reference for formatting or whatever. And then you'll have page-specific JavaScript. So that's what you want to do. In your global library, you want to create the namespace for your app. So it's like window.myapp, and then use that object to put everything behind that object, right? You should have nothing, nothing above that object. Treat that as your global scope, and work with that going down, right? So yeah, I need to go back. I'll show you this in the demo. So put stuff in your library, page specific there, and then rename the files when you publish to break the cache.
Chris,
yes, sir.
Why is that? Isn't just a fresh date on the file sufficient?
That's fine too. It's just like most people don't know what server config is, and you know what I mean. They don't know how to change their cache. If you're in charge of your server and you've got your cache headers, then that's totally fine. Don't worry about it. But it's usually if in your build process, in your build script, it's often like a 1-line thing to change the file, and it will totally prevent any kind of that'll work with any server config you have. Okay. So the default for most configs is to cache for a long time, and so it just works well with that. But if you know what you're doing, then by all means. Like Google definitely does not rename their files when they update, but they they know what they're doing. Okay, so I needed code to show how this works. So I'm going to show you a website that I have that does this. Okay. I don't follow all of my rules in this, but this rule I do follow. So here we have this is my development version. This is production. So this is source for development, source for production. So we see at the top, right, we got my base file, my main file, and these are not minified. Right, this is readable, I edit this. This is what I want to see automatically. Go back. Here we have the same file, right? So we're reducing HTTP requests, rolled up, and we give it a hash. And it's small, right? And then at the bottom of the page, I've got my library, my global function, Google Map API, which I need on this page, another file for this page, and then the home page, right? And if I click on these, it's all readable, right? So let's click on my global file, and we can see here I'm adding something to the string prototype, right? I'm creating the global site namespace. That should be window.pu equals window.pu. Here's some images I need. Here's some global, right? So this is stuff I need on every page, okay? And then at the bottom I have the home page. And you see that I'm creating an anonymous scope, right, at the top, and I'm closing it at the bottom. Remember that closure example, right? I'm creating this in a scope of its own, and I'm executing immediately. And all the stuff inside of this, I'm basically exporting it out of that anonymous scope. So I'm adding something to a DOM element, or I'm running a function immediately, right? And so inside the scope, if I have a function up here that says, like var gmap is a really good example, right? It's the Google Map instance on that page. Remember the count object, the count variable, right? It's there, it's existence. It's in memory, we can't change it. We can't mess with it. Same thing here, right? This gmap variable only exists inside this anonymous scope. And all the functions I need for it to operate on that map, when you click on the elements and stuff comes up, that's all inside this scope. Make sense? Raise your hand if you're kind of tracking that. Not as many people. That's okay. That's okay. I'm mostly trying to get the optimizations in here. So where am I? So the bottom, it's just 3 files, right? I roll up my library with my global file. Google Map API has got to be external call, and then those 2 files become 1. So when I change,
A nifty trick, if you don't have to change the file every time, shove a question mark in the end of it.
Yeah. You don't have to. Yeah, you don't have to change the file name. You can do add a get parameter. It's going to function the same way. So let's do this, right?
Why can't you combine pulled your ultimate simple files into one?
Okay, that's a great
You were
question.
complaining about.
I can't, right?
Okay.
This file's on every single page. This file is not. So whenever people visit the page, and assuming they're going to visit multiple pages, they're going to download this the first time they visit and then never again.
Well,
Make sense?
how many of those were explainable for the bootstrap? Maybe some of those were
No, none of them.
page and.
None of them. That I'm not giving them.
I mean,
Like I'm not calling them out. That's just a development site, but that comment bothered me. You're not really optimized.
Some of those must be collapsible into fewer than 10 lines.
Yeah, definitely. Right. So, like for example, if you have a website that it's some jQuery plugin, I hate that word relative to jQuery, but it's like 15 lines and it's its own HTTP request. No, don't do that. Roll it up. All right, roll it up.
Wow.
I'm going to show. So your build. Let's just like edit this. So this homepage file ends in 13 EA6, right? It's recompressing that. It's going to concatenate it all together. And what is it? Different file name. Right. So if with the change, I want you to get that change, and I publish it, you're going to get it. You can't not get it. Both files are gone. Delete it. All right, back to the.
So that renaming the file is handled by the compressor.
I've got like a publish script that does it.
So it's not part of the UI compressor.
Okay, that's the demo. The thing is, this depends on your application, right? That's for most people for most applications. But if you have something that's like all on one page and you're using X, the rules for you are going to be different. If you're doing a lot of async libraries, the rules are going to be different. But that's something that people could do that would help them out in most cases. Yes.
What was your module pattern and where you export your data in your demo?
That was So that's when I'm creating that anonymous scope.
Oh,
So you're creating an anonymous scope and you're basically exporting things out of it. It's called the module pattern. Okay. Miscellaneous recommended. I already covered this, but do your functions like that, just so you know. Use a CSS reset or a normalize if you're into that kind of thing. Use the closure linter and the Google style guide for your code. This is great. Let's say this is really good if you're on a team. Okay. If you've got a large JavaScript code base, Google produces this closure linter that you can run on your code and will warn you of things that don't match their style guide. And if all of your code conforms to the linter, then that's sweet. That's really going to help your team. It's going to make things easy. It's just a standard. It's a standard that you can just say, we're going to do this. Number one, there's no argument. You just kind of do what they've done. And number two, here's a free tool that tells you when you're doing it. Why wouldn't you use that? Right? So, I mean, anybody who's got a team of code, I highly, highly recommend both implementing the style guide and also using their linter tool. I would rather have, like, if I had a big code base in JavaScript, I'd rather have it conforming to the linter 100% than, like, rewrite it in CoffeeScript, for example.
How does that compare to JS9?
It's similar. It's similar. This is stricter.
More strict?
Yeah.
Is it possible?
Oh no, it may not be more strict. Lint has all these options. It's pretty strict. It's pretty strict. You can turn stuff on, off and on. So if you decide that there's something that you care about, you can turn it off.
$1 line per function.
Yeah, you can just throw options to it and say, don't do this check. It's really pedantic. Have a one-step build deploy process. That's kind of outside the scope of JavaScript, but you should have that anyway. Develop on a server. This is something I learned at CPAN that I really like. So like your development environment is really important. And a lot of people develop on localhost and they have it in Git and they can move around. But if you develop all on the server, then your environment's with you, right? And like shared hosting is really cheap. It's really cheap. So you can pay $10 a month and have someone else worry about all the metal. You SSH into your environment. I do all my development on server. I just highly recommend that. It's going to depend. Obviously, that's going to depend. Like if you're not doing websites, it probably doesn't even make sense. But I recommend that. When in doubt, be more explicit. That's especially true for a language like JavaScript. And then smart data structures and dumb code works a lot better than the other way around. That's from Art of Unix Programming, I think, by Eric Raymond. That's really true in JavaScript, right? We can create these really powerful data structures in JavaScript with nested objects and arrays. And it's way better to have a nice data structure right? And stupid code than the other way around. So highly recommend that. That's kidding. Okay. Unsolicited advice. I am famous for giving this to my friends. Take all of this with a grain of salt, right? Take it like, if you don't agree with it, then like, don't worry about it, man. Don't worry about it. But this is just stuff that I felt like I had to give. I couldn't get up in front, get up and talk in front of a bunch of programmers without mentioning this stuff. Again, this is like Pareto's law. There's a ton of the stuff you could do, but if you do like a little bit of it, you might get most of the benefit. So let's take it. Okay. Prefer books to blogs, right? I mean, raise your hand if you just read blogs all day. The thing about I love blogs. Blogs are great, but anybody can write a blog. There's no vetting process, right? For a book to get published, the publishing company had to recognize the author as an expert, had to get, had to go in negotiation with them that they're going to do it. You have some credibility there from the system with an author of a book over a random blog post. They're professionally edited, which means often the content is a lot better. And this is the most important thing, is that they have cohesive content. So you can imagine that Twitter developer reading some single blog post about put your scripts at the bottom, but it didn't put it in context of the optimization where you should have less files is more important than that. Well, you would have had that in the book, because that would have been chapter 2, and chapter 1 would have been, roll your stuff together. So I highly prefer books to blogs. Next one. Prefer advice that has stood the test of time. This is true. Everyone loves the new hotness, man. Did you get that new thing? It was on GitHub 6 hours ago, Yeah. Okay. The Unix philosophy is ancient, right? And is like the best advice ever today. Probably 20 years from now, it will still be relevant, right? The Mythical Man Month. So this guy, what was the guy's name? Fred Brooks? That's Fred
right.
Brooks. So Fred Brooks, I think it was IBM?
Yes.
I think it was IBM, yeah. So Fred Brooks was a project manager in IBM. Wrote this book in 1975. It was the worst project ever, which it was just like all software projects, right? It was over budget, it was late, and IBM was like this, established company, and they're like, how did this happen to us? You know what I mean? Like, you're a professional project manager, you had experience, these were professional programmers, they were experts. How could we be over budget and late? And he was like, God, you're right, this was crazy, I'm gonna go write a book on how this happened. That was 1975.
Yeah. Well,
right?
The project was 64. It was System 3.
Okay. Even later, right? The advice is still solid today. Raise your hand if you've worked on over budget, late projects. It's everyone, right? I mean, I see it today.
Have more people, right? Isn't that the solution?
Yeah. So, the point is not, and then, it's not. This is not the final book on project management. Just the point is that you don't need to read, the book that's 6 months old. There's good advice that's old that applies today. Human beings haven't changed. I don't know if you guys know. This is a similar thing. It was like a social piece of software, and they basically learned that you can't distinguish between social rules and technical rules, right? And then Clay Shirky did a write-up of this, and it's really, really insightful. And it's basically like people talk about Twitter and Facebook and how it's changing us. Like, they should just read this. It's the same thing, all right? So I'm saying this stuff doesn't change. Think back to 2005 when you're developing a web application. Man, we gotta implement RSS. Everyone's using RSS, right? Oh, that's so important. That takes precedence over a faster website. Who cares? Who cares about RSS? Raise your hand if you care about RSS. Like one guy, right? 2 guys. So it's 2007. Oh, let's get Dig on this, right? Now who cares about Dig? So I'm just saying, right? Nobody's ever gonna want a slower website. Prioritize stuff that doesn't change. I'm not ditching on Facebook and RSS. I'm just saying, if you had a choice, go with the thing that's not going to change. Right? I mean, those are easy. But you get my point. That's the problem.
If you get to 2020, it might be, what's a website? Oh, it's that icon on my phone.
Yeah. I mean, obviously you got to balance. You know what I mean?
That's right.
You got
inside Facebook. It's a website.
Yeah. Okay, prefer in-person networking to synthetic. So I've got all this email and I've got all this Twitter and Facebook and text messages, and that's great. Those are communication tools. Those are not relationships. Relationships are built in the flesh. In-person, we are these ancient animals with a ton of expressive power with nonverbal communication, right? Clothing, eye language, right? Your in-person communication is always going to be more expressive than anything else. So I'm not saying don't use these tools, but develop relationships, and they happen in person. Life doesn't happen in a vacuum. and then new tools. Okay. Prefer creation over consumption. You're going to learn faster, right? Aim for quality and not quantity. And then this quote really just sums it all up. So when you don't create things, you become defined by your tastes rather than your ability. Your tastes only narrow and exclude people, so create. And that's by a good programmer. So creation is awesome. And quality creation is even awesomer. Yes, sir.
Don't rebuild the wheel.
Don't what?
Don't rebuild the wheel.
Yeah. I mean, I agree with that. This doesn't.
I'm balancing it.
This says, yeah. I mean, this says nothing about. I'm not saying rewrite things have been written. I'm just saying, like, okay, so, like, let's say you write a JavaScript parser in JavaScript, right? Number one, that's already been done. It's already been done way faster than you did it. But guess who's an expert in JavaScript parsing now? Right? And that's a hard thing to do. So if you do that, you know what I mean, that's important. Remember, grain of salt too. Like, if you don't agree with this, just like write it up. Tools and environment. Oh, this stuff is so important. This stuff is so important, and it should be. You should always think, just like in software, when you're thinking in the context of your application, you should always think in the context of your development. What am I doing here? Is this the appropriate tool for the job? Is this the appropriate context for me working? A lot of times when people have errors, like I had this friend, and she like posted on Facebook about something that happened, and she had basically like dragged a file, she'd like dragged a file onto her FTP editor to publish, and overwrote the file she was editing, so like that, right? Just like a mistake, right? Raise your hand if you've done that. It's the time of your life. Everyone's done that, right? Well, I kicked the last thing. So like, that's a function of your tools and your environment. I mean, that's human error. But if you were working within a system that didn't allow you to do that, like if you had a publish script, like my publish script can't mess up, right? I mean, I could make an error in writing my publish script, but it's not going to mess up when you know what I mean? I'm never going to have that error that she had because of the process and tools. So the idea here is pick powerful tools and learn them well. And I'm not going to talk about what tools to learn, right? Because that's a religious sport. But pick a tool that's powerful enough and learn it well. Amplify. You want to amplify your ability as a programmer. This applies. So some common examples: text editor, source code control, bug tracking, build deploy tools, and what's the best platform? You know, are you building a .NET app? You should probably be on Windows. You know, if you're building an iPhone app, you should probably own an iPhone. Right? It's like, right?
I have a question. Yeah. Earlier you said you develop on the server.
Yeah.
Do you give up your preferred text editor, or how do you combine the? You give up some tools if you're working.
So like what I mean by that is I'm in my editor. When I click the save button, it's saving it on the server. That's what I mean.
Oh.
But like plenty of people are going to be using VI and Emacs on the server in the shell.
That's what I thought.
And I'm not. Again, this is not anything specific. I'm just saying generally. Pay attention to your tools. Pick powerful ones. Make sure you really know them. Don't give yourself the ability to throw an error. The same thing applies. You're just a really complicated monkey, right? So keyboard and mouse, typing speed, monitor size and pixel space. I just say monitors, because you should be using more than one monitor, definitely. Desk and chair, noise, lighting, sleep, and caffeine. These are all things that are going to affect your performance. Right? You're not software. Huge. Recommend that highly. I use those like every day, all the time. I mean, I have sensitive hearing, but I'd recommend those big time. You might just try with those and not, and see if it makes a really big difference. It does to me. That's miscellaneous stuff. Okay, yeah. Bugs are relative to time. Like, it's amazing how much development process doesn't take this into account. So if you create a bug, and someone finds that bug 5 minutes later, you have the context for that code in your head. So the cost for you to go and fix that bug, oh, I know what that is. I just introduced that. Boom, fixed. Right? So like, raise your hand if you used a bug tracker before, right? And like, raise your hand if your bug tracker is set up so that the time of the bugs is a high priority. Like, nobody's got their hand raised. That's insane, right? So the quicker you find bugs, the quicker you can fix them. An old bug might be written by someone else. You're out of context for that. Old bugs are dangerous. New bugs are really easy to fix. So it's just amazing how much people don't think about that. That affects your development process hugely. All right, this is if I had to say in like a single sentence, this is why waterfall is bad. Right? The iteration time is too long. It's basically like writing the software multiple times instead of like a flow.
So are you a TDD fan for JavaScript?
No.
No.
But that's like like, my answer to that is like, it's tangential to this. This is kind of what I'm saying. I'm just saying that, like, I don't care what your process is. I'm saying that bugs are going to happen no matter what. And you just want that feedback loop to be as fast as possible.
Continuous integration, you're a fan of that?
Sure. I don't like to put labels on it, you know? Like people, I'm serious, like,
We don't want to pin you down here.
yeah, because time is linear, and everyone understands time. You know what I mean? Like, guess what? We publish every Tuesday at 6 p.m. When are you going to publish? Tuesday at 6 p.m. Like, it's just, it's built into our lives. I don't know why there's so many processes that don't have that built into the schedule. It's amazing. You want the time between developer eyeballs and user feedback. You want that loop to be as short as possible. Okay. And, all right. Meetings about software are mostly useless and often harmful. Okay, so this is a quote. It's from one of my favorite books. And there was some research done in like the 70s in the nutrition field, and the results came back, and they published it. And some of the scientists said, "Well, this is great, and we think this is definitive. We think this is conclusive." And some of the scientists said, "Well, we're not sure." And so the government said, "Well, we need to know what the result of this is, because we need to tell people." What to do. We need to give them advice in this area. So we need to know, good or bad. So the government had this consensus conference and brought the scientists together for 2 weeks, and they sat around in tables and they talked and they discussed it, right? And at the end of the conference, it was like 9-1 or 8-2 or something in favor of this is good research. We all believe this. And so the government went with that. The consensus was that it was true, and then they told people all this stuff. Okay? So 20 years later, right? Now we have the technology. Oh, it was wrong. We were wrong. It was bad research. This is the quote from the dissenting scientist, right, in the 70s. If there had been true consensus, you wouldn't have had a consensus conference. Right? There was never a consensus conference on gravity, right? So this is really true with software. Meetings are all about social dynamics and group dynamics and getting people to agree. And there's all these social factors involved. And that's not what you need. I mean, you need that for a lot of things in your life, but it's the opposite of what you need in software. With software, you need one thing, and that's specificity, right? So coercion is likely to happen in meetings. Whoever, has the strongest voice, or the most powerful person in the room is likely to, get people to agree to what he's saying, and it may not be the best decision. So this is how bad software gets designed. I would much rather have, and this is for the same reason, like a spec document is basically a useless document. Give me a mock-up that I can see with my eyes. Because if I have a spec document, it's written in English, and 10 people read it, we're all going to have 10 different ideas of what the software is going to look like and going to function. If we see an interface, that's the interface, that's real, right? We can see and know how that operates. Like if you have a documented API where the calls are documented in and out, that's specific. If you have a spec sheet where we're going to do this by the 3rd of April, it's not specific enough, right? So and the problem is that you need all that in business, and you need it in marketing, you need it in negotiation, right? And so that creeps into our world, and it creates bad software. That's probably my most controversial point. And if you, okay, one more thing. If you must have a meeting, do a hard egg timer or do it while physically standing. That will immediately nullify some of those group dynamics, right? People don't like standing for long periods of time. Okay. One more thing on that. That basically you can achieve a lot in email and non-verbal communication. So email and messages and stuff like that. Okay. In line with books versus blog posts, I mean, like there's find some problem in JavaScript, type it into a search engine, and it comes up with someone's blog post. Who is that guy? I don't know. Maybe he's just some joker who has like a quota for blog posts for that month. These people are totally worth listening to, right? Douglas Crockford worked at Yahoo. He's on the EMCA board. He wrote the good parts. This guy's the godfather of JavaScript. Steve Sodders worked at Yahoo, now works at Google. He's into fast websites, and he's really an awesome person. He's pushing research forward in areas that other people aren't. Stoyan Stefanov works for Yahoo. He basically does the same thing for Yahoo that Steve Sodders does for Google. He's pushed his job. He gets paid like a high salary to analyze browsers and find ways to make them faster. Why would you not listen to that guy? He's a great guy. He's also funny. Paul Irish works for Google and is he's also on the jQuery core team. He works for Google on the Chrome team as like a developer evangelist. He's also a really bright, funny guy who has good information. Restig is the creator of jQuery. He's really brilliant, and his blog posts are great. Sometimes his blog posts are not useful for like day-to-day though, because he's dealing with really, sort of abstract, intricate stuff, but I would be a crime not to put him on this list. And then Brett Victor isn't really a JavaScript guy, so to say, but I had to put him on this list because every developer should listen to what this man has to say. So that's good. Okay, resources. Read this book, and then read it again, and then read it again. This is a good book. This is advanced, but it's got nothing on this book. If you read this book, right? This is a really good link, and these are, you can get these slides. I can show you here. I'm gonna link these slides. This is a long document on how browsers work. So if you ever wondered exactly what's happening in code, but you didn't know how to read like highly optimized C++, then you can just read this and you'll know how it works. The Google JavaScript style guide, I mentioned that earlier with the linter, highly recommended. Yahoo Central Performance team, they put out good stuff. And this is that video I talked about by Paul Irish about the what's new in HTML5 and what you can safely do and how it works. That's like 45 minutes to an hour. It's definitely worth your time. And that's it. If you play poker in Houston, shoot me an email. And the slides are here. And Chile.